Hello students, welcome to Day 1 notes for the unit The Gas Laws. Today we are going to review very quickly kinetic molecular theory and then introduce ourselves to the first couple of gas laws. After today you should be able to explain the factors that affect gas pressure, describe some real-world experiences and how they relate to gas, pressure, temperature, and volume, and predict the behavior of a gas by changing one of its variables. First, we're going to review a little bit about kinetic molecular theory. If you recall from yesterday, kinetic molecular theory makes three major assumptions about the particles in a gas. The first thing we assume is that the particles move in a straight line until they collide with other particles or the walls of their container. The second part of kinetic molecular theory is that the motion of these particles is constant and random. And the third major assumption about kinetic molecular theory is that there are no attractive or repulsive forces among these particles. When we talk about gases, there are four variables or things that can be changed regarding that gas. These four variables are generally used to describe a gas. The first of which is pressure, which, remember from yesterday, can be measured in kilopascals, millimeters of mercury, or atmospheres. The second variable is volume, which will be measured in either liters or milliliters. The third variable is temperature, which must always be measured in Kelvin. You may want to make a note that sometimes this will be given in Celsius and you will need to convert to Kelvin. The final variable that we'll talk about is the number of moles or the amount of substance. First, we are going to discuss the effect of adding or removing a gas from a container that's under pressure. When the amount of gas in a given volume is increased, the pressure increases. Let's look at an example doubling the amount of gas. In the first container, the one on the left, we have 5 particles of gas. In the second container, we have doubled that amount of gas to 10 particles. What do you think is going to happen to the pressure because we doubled the amount of gas? If you said that the pressure was going to increase, you are correct. 2 times the amount of gas means that the pressure will double. More particles means more collisions, which means more pressure. This is a direct relationship. If the number of particles double, pressure doubles. Remember, in a direct relationship, if one variable increases and the other variable increases as a result, it is called a direct relationship. Let's look at a real-world example. Whitewater rafting. The strength and flexibility of the raft are important when you go whitewater rafting. Think about it. The raft must be able to withstand the pressure of the air inside the raft and the force of the rapids below. If the raft is too inflated, too much gas is added. The raft will easily burst. But if not enough gas is added, the raft will not stay afloat. Let's look at the effect of changing volume of the container of gas. When the volume of a gas is decreased, for a given amount of gas pressure increases. Here's an example. Decreasing the volume of the container by half. If you'll notice in both containers, both the one on the left and the right, there are 5 particles of gas. But take a look at what's happened to the second container. Its size has been decreased by 1/2. Therefore, its volume has decreased by 1/2. What do you think will happen to the pressure? If you said that the pressure would increase, you are correct. The gas has 1/2 of the volume to move around in, or 1/2 the space, therefore the pressure will double. The particles are closer together in the container, which means more collisions, which really means that there's more pressure. This is an indirect relationship. If the volume is halved or decreased, the pressure is doubled, that means increase, and vice versa. Remember, when two variables, one goes up and the other goes down, it's called an indirect relationship. Let's take a look at another real-world example, opening soda cans and bottles. Soda cans or bottles are usually opened slowly because we've learned that popping them open too fast causes it to fizz up and spill all over the place. When you open the cap, the gas is suddenly able to increase its volume in order to decrease the pressure inside the can. Therefore, gas is going to try to escape the can. Shaking a carbonated beverage causes the gas bubbles to mix with the soda, and before some of the gas can settle out, you've got quite the mess on your hands, now don't you? Let's look at the effect of changing temperature on a gas. When the temperature of a gas increases, the particles have more kinetic energy and pressure increases. Remember, when you change the temperature or increase the temperature, particles are going to move faster, therefore making more pressure. Here's an example, doubling the temperature. If you take a look at the two containers, both of them have 5 particles of gas and the same volume. They should have exactly the same amount of pressure. However, the first container is at a temperature of 298 Kelvin. The second container has the temperature adjusted to 596 Kelvin. What do you think is going to happen to the pressure in the second container on the right? If you said that the pressure is going to increase, you are correct. Doubling the temperature is going to result in 2 times the pressure because the particles are going to move faster, pressing more on the walls of the container. The particles move faster when heated and strike the walls of the container with more force, so the pressure builds. This is a direct relationship. If the temperature is doubled or increased, pressure is doubled or increased, and vice versa. Remember, when one variable increases as the other variable increases, it's called a direct relationship. Let's take a look at another example. Another real-world application is aerosol cans. That's spray cans. A gas in a sealed container can generate an enormous amount of pressure when heated. That's why all labels on aerosol or spray cans say do not store above 120 degrees Fahrenheit. Even empty aerosol cans still have some gas in them, so they will explode if thrown into a fire due to the increasing pressure. It is also wise not to store cans at temperatures that will freeze the substances in them. Freezing causes the substance to expand and will puncture the can. Any questions? Then you are now ready to complete Worksheet 1. Remember that you can go back through this video, pause the video at any time to write down extra notes or to look at things a little more closely. Good luck on your assignment.